So we are already aware that what is graph? Graph is a collection of vertices and edges, or in other words, we can say uh, nodes and edges, right? So our graph looks something like this, right? So there is some concept known as spanning tree and minimum spanning tree. So what is it? Like suppose we have these nodes and these edges. So for creating minimum spanning tree, the condition is we need to traverse each and every vertex. Traverse in the sense we need to visit each and every vertex. At the same time, we need to use minimum number of edges to visit or to traverse every vertex. So that is something known as minimum spanning tree. So to create a minimum spanning tree, to come out to the minimum spanning tree, we have two algorithms, namely Prim's algorithm and Kruskal algorithm. So in short, we will see an example from this Prim's algorithm. So let's suppose we have this graph, example graph. So for this, let's suppose we want to create a minimum spanning tree. So we will let's start from C. So how many adjacent vertices are there to this C? One, two, three, four, five. But whose cost or whose weight is minimum? These are known as weight. The numbers on the edges are known as weight. So which one is minimum? This two. We can add this C, B. So now C is visited, B is visited. Done. So we traveled C and B. Then next, this E is the minimum. So we can do this. This is visited. Now, from E, in how many ways we can go? Only to F, right? So we will visit F. Let's visit F3. Done. Now, from F, we can go to C and we can go to D. If we go to C, is there any need to traverse C? No, right? So, and its cost is also 4. So, we will go to D and it is visited now. D is visited 3. Now, which one is left? We can either go, A is left, right? We can either go from C or B because cost from B to A is 4 and cost of B to C to A is also 4. So, we can choose either of these. Let's suppose if we choose this. Done. This is the minimum spanning tree, and the condition is we need to use less number of minimum number of edges, and the cost, the weight must also be less. So how do we find out the weight? We need to add all these numbers written on this. So this is about Prim's algorithm. Very similar to this. There is something called as Kruskal algorithm. So how do we do that? Let's take this example. Let's write A, B, C, D, E, F. First, we note down what is the minimum to maximum cost. For example, BC. BC's cost is 2. Then CE cost is 2. EF cost is 3. D and F cost is 3. DC cost is 3. Done. 2 is done. 3 is done. Next one is 4. AB cost is 4 and AC cost is 4. Now we will start. So let's suppose if we want, we will start from BC. Okay. B to C cost is 2. This is done. Now can we use this CE? CE? Yes. B is visited, C is visited. Now we will visit E also. Its cost is 2. Now It is also done. EF, 3. EF. Can we use EF? Yes, we can. It's visited. 3. Now, can we use DF? DF3? Yes, we can. So we will use this D3. This is done. Now, is there any need to draw an edge between DC? No, right? D is also visited, C is also visited. So we will not use this. Then AB, is there a need? Yes. So we will write A for A is also visited. So the each and every node is visited now. So there is no need for this. We are done. Add up all the edges and we are done.